Here is example 3 from our ellipses lesson. This one's a little bit more involved. Notice this is the general form of an ellipse. It does not have our h, our k built right in. So we need to rearrange this one like we've done with circles, like we've done with parabolas. If it's in general form, let's rearrange it and put it in standard form. One difference on this one, when we did this with circles, these coefficients were the same, and they always will be for circles. We could just divide it through, but I can't divide this out because they're two different numbers. So here's how we handle this. Let's group our x's together and our y's together. In fact, let me just rearrange it. Let's do that first. So we've got 9x squared minus 54x. So I'm just grouping right now. Plus 4y squared plus 40y, so group those y's together, equals negative 37. If we take that over, that's not really doing a lot for us. Now let's get this ready to complete the square, just like we did before. The difference being now we've got numbers in front, so we have to factor those out. So watch how I do this. So I'm going to pull a 9 out of my x's. So 9, that would leave x squared minus 6x plus something. Leave myself a space there to complete the square. I'm going to pull a 4 out of my y's. So I'd leave y squared plus 10y plus something. Of course, I still have that negative 37 over there. And now we're going to complete the square. So half of 6 is 9, or I'm sorry, half of 6 is 3, squared is 9. I was getting ahead of myself. So 9. Now this is just a little different than what we did before. Notice normally I just add a 9 to both sides, but this isn't just a 9, it's actually a 9 times a 9, because we have that 9 out front. So I'm actually going to add 81 to both sides. And now here, half of 10 is 5, square that. And we'll add 25. So now I added 4 times 25, so that's actually 100 right there. Now let's clean this up. Let's see what we have. So 9 times x minus 3 squared. I hope we're feeling pretty comfortable with this completing the square process. Refresh your memory. See how that works. 4 times y plus 5 squared equals 144. Okay, now we're really close to standard form. But in a ellipse like this, standard form, you don't have numbers out in front, and it always equals 1. So let's divide this 144 by both sides, and let's see what happens. Now sometimes this confuses us, but all we're doing is reducing a fraction. So in fact, let me just bring in my calculator and illustrate that. So if I did 9 over 144, oh, that's just 1/16. Or in other words, 9 divides into 144 16 times. So I can rewrite that. X minus 3 squared, that's just over 16. Let's do the same thing. So 4 over 144. So 4 over 144, that is 1/36. Or 4 goes into 144 36 times. So y plus 5 squared, of course that hasn't changed, over 36 equals 1. Now that looks like our standard form. And by the way, when I reduce those fractions, what if they didn't reduce nicely? What if I got like 3/5 or something? Well, that's okay, but you're not going to leave a number on top. You would actually just do its reciprocal and write it on the bottom. So if I had 3/5, I would write 5/3 as my number in the bottom. I don't know that we'll run into many like that, but you just want to make it match standard form. Alright, let's identify our center now. I'll just come over here by our graph. So the center we've got is 3, -5. Let's go sketch that. So 3, -5. Where are we at? 1, 2, 3, 1, 2, 3, 4, 5. So we're down there. And I'm going to go off my graph a little bit. I wanted to scale this one differently. I should have. That's okay. I'll just leave it how it is. So my major vertices, we're going to go down 6, up and down 6. So 1, 2, 3, 4, 5, 6. Here's where I'm off my graph. I'll just throw it in here. Sorry. 1, 2, 3, 4, 5, 6. Let's say we're down there somewhere. Let's identify those points. So I would be at 3. If I'm at -5 and I go up 6, I'd be at 1. And I would also be at 3. If I'm at -5, I go down 6, I'd be at -11. Okay. And my co-vertices, I'm going to go over 4, it looks like. So 1, 2, 3, 4. 1, 2, 3, 4. Let's identify those points. So now if I was at 3 and I went over 4, I'd be at -1. Of course my y value is not changing for these ones. And if I'm at 3 and I go over 4, I would be at 7. So 7, -5 for those. And then again, let's just kind of sketch it in. And there's my parabola. And whether you do it in the, or my parabola, my ellipse, I'm sorry. There's my ellipse. And whether you label the points right on your graph or off to the side, or both, either way will be fine. We just want to be able to recognize those key components.